We have 7 over 4 pi. Now, you know that if we had 4 over 4 pi, that would be, right over here, and we'd say, okay, 4 over 4 is the same thing as 1 pi. But this is more than that. In fact, this is almost 2 pi, honestly. Halfway around is pi, all the way around is 2 pi. And 7 is very close to 8 over 4, right? 8 over 4 is 2. We didn't quite make it all the way around, but we were very close to 8 over 4. So we're going to cut this off. Think about this with me for a second. If we have 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4, 5 out of 4, 6 out of 4, 7 out of 4. 8 would be all the way around, but 7 out of 4 means we're stopping right there. How many degrees left would there be? Well, that's the 1 out of 4 we don't have. So what's 180 divided by 4? Because pi is 180, right? So 180 divided by 4? 45. So that's a 45-degree angle right there. Left to go. So let me draw a better drawing. I just wanted you to think about 1, 2, 3, 4, 5, 6, 7, almost 8. I just wanted you to think about that. Let me draw you a better drawing. We'll say, you know what, instead of doing all that, let me just kind of think about it backwards, and I'll just say, I'm going around, but I know I'm going to be left with 45 here. So let me just draw that, okay? And this is 45, and this is 45. So I've got my 45, 45, 90 triangle. And I'm going to label this because I know the sides are 1, 1, and square root of 2, because I have notes somewhere, or I just remember this from my memory, okay? And I say, oh, the cosecant. What in the world is the cosecant? Well, it's the upside down sign, okay? If you look at your notes also tell you it's sine under 1, so we're going to find the sine of 45 and we're going to flip it, okay? Same old thing like we always do. If we get one that's the upside down version, we find it like it's a normal sign and then we flip it upside down. That's all we do. And so we have to think about the sine of 45. And SOHCAHTOA. What does SOHCAHTOA tell us about the sine? The sine is equal to exactly opposite over hypotenuse, because sine is so. Yeah, okay, so what's the opposite of this 45 right here? It's a -1, right? I know I didn't say negative, but it's going down under the x-axis, right? So it must be -1. So I have -1 over the hypotenuse. What's the hypotenuse? Thank you. And so I have my sine of 45, and I'm going to flip it so that it's really the cosecant. So I'm going to put the square root of 2 on top. Let me erase this red line. Square root of 2 on top, and the 1 on the bottom. Do I really need to write the 1 on the bottom? I can skip that, right? But don't forget it's negative, okay? Does anybody need me to put the 1 on the bottom to feel better? Or are you okay if I leave it off? Does that bother anybody? It's just this upside down. I want to make sure are you cool with that? You okay? Okay. Is that all right? All right. So we got the first one. It's a negative square root of 2. Okay. Let's do the next one. Oh, look, this is pi over 4 again. What did we say that pi divided by 4 was? What's pi divided by 2? Pi is 180, right? So 180 divided by 2 is what? 90. And then if we divide it by 4, it must be 45. So we're going to go negative 45. Well, we already did that, right? Because if we go down here, that's negative 45, right? Because the first time we went around 7 out of 8, and we stopped there. So we went positive 7 out of 8, 7 out of 4. 7 out of 4. And so we got there in the positive direction last time, that we went that way. Now we're just dropping down one of those, but it's the same place, okay? Whether we went 7 out of 4 that way, or we just went negative 1 out of 4, it's the same place, right? So I'm just going to use that picture again. I don't need to redraw it. It's the same thing. And I'm thinking about secant. Secant is what? It's 1 over cosine of whatever our angle is, so I'll say theta. 1 over cosine theta. So I'm going to find the cosine of that, and I'm going to flip it upside down. Okay, and don't forget it's negative. Don't forget it's negative. We don't want to forget that when we're all done. We have a negative sign out in front. Okay, so the cosine of 45. What does SOHCAHTOA tell us about cosine? So CAHTOA. So we have CAH from SOHCAHTOA. CAH, the CA. So cosine equals, what's the A? The adjacent? Uh-huh. And what's the adjacent to that 45? Yeah, that one right there. It's a positive one because it's on the x-axis, right? It's positive there. So we're going to say 1 over, what's the hypotenuse? Square root of 2, thank you. And we're going to flip it upside down. And I'm going to put this negative sign on it because it said minus, so it's going to end up being negative, right? I know this was positive, but it's being subtracted. So I'm going to say negative square root of 2. That's for the second part. So we have two parts, and they're exactly the same so far. I mean, they're not, but we're subtracting it, so it ends up being the same. And then tangent. And I want you to think about tangent, the tangent of whatever we have. Let me ask you about this first. 3 pi. Seems like there's extra pi that I don't need. I like to get rid of all the way around. You can never have too much pi, is that what you said? Yeah. If you go all the way around, how many pi is that? 2 pi, right? And so I don't really need that 2 pi, so I'm going to take the 2 pi away. And I'm just going to say tangent of pi, right? Because if I go around 2 pi, where did I go? Well, I said I went somewhere, but it doesn't look like it. So I'm just going to say pi, tangent of pi. And that's the same thing as 180, right? And tangent is equal to the sine of pi, but instead I'm going to say 180, same thing as pi. 180 over the cosine of 180, because that's what tangent does, sine over cosine. And I want you to think about something with me here. When we found the sine at 45, were we finding the x direction or the y direction? Y? Yes, sine had something to do with y. So this is going to be about the y. And when we found the cosine of 45, were we thinking about the x or the y? We were thinking about the adjacent up here on the x-axis, right? Okay, so this kind of helps us think about this. Because when you graph tangent of pi, you have to go all the way over here, and you get this line that's flat down here at pi. And there's no triangle. We can't build a triangle with a flat line, can we? Everything else we could build a triangle. If it stops here, no problem. We build a triangle. Here, I can't build a triangle. It's just laying flat. What can I do with that? It's one line. I can't. So that means there is no y value. See the y up here that's supposed to be on the top? Well, there's no y. It's 0. So I'm off the hook, okay? If there's 0 on the top, I'm done, okay? It's 0. If it was up just a little bit, I could say there was a little bit of y, and I could find the sine of whatever that is, and I'd have some y value. But it's not there, so it's 0. So I just have negative square root of 2 and negative square root of 2. If I put those together, I get 2 of those, and they're negative, right? I get negative, I have one of those negative square root of 2, and then I have another square root of 2, and it's negative. So I have 2 negative square roots of 2. That's it. I just added them together. They're both negative, so I got 2. Here's one, this one right there, and here's the other one. So 1 plus 1 is 2. Oh, what they're negative. Negative 1, negative 1, negative 2. And I still have, I kind of treat this like it's a letter. I have a negative x, and I have a negative x, so I have a 2 negative x. That's all. Okay? I know these aren't easy.